Alrighty, question 2. So this is the bomb question. So what we have here is a bomb, which is on the output of our logical circuit here. And what's happening is that we have think of like a 4-bit register here that's counting down from its top value of 15 all the way down to 0. So what's going to happen is, if we get an output of 1 to our bomb wire here, the bomb's going to explode and we're going to die. And that wouldn't be very nice, would it? So we have to work out in part 1 what number here is going to set the bomb off. So what we actually want here is the first bomb, is the first number that's going to set the bomb off. Now you could do this by doing a truth table, but I think it'll be a little bit easier if we just count these numbers down until we find the first one that sets off our bomb. So first of all, let's go through and identify all of our gates again. So up here we have an OR gate with a dot on the output, so we have a NOT OR. Now what else do we have? Here we have an AND gate with a dot on the output, so that's going to be a NOT AND. Yeah, an AND. Over here we have a regular OR gate. And we have a NOT down here. Okay, so we've identified all our gates. Let's see what the steady state, or the all one state of this circuit is. So we have all ones in here. Now, the most important gate in this circuit is the NOT OR, so I'll just quickly draw out the truth table for that. There we have A, B, and NOT OR AB. So it's an OR gate with a NOT on the output. So this is going to look something like 1, 0, 0, and 0. Okay, so in order for our bomb to go off, both inputs to the NOR gate need to be 0. So let's think about the first time when that's going to happen. If this bit is a 1, then this gate will always be a 1, because anything ORed with 1 is 1, and we'll have a 1 here, and we'll have one of these conditions. So if this bit is a 1, this wire will be 0, because the NOT OR will have a 1 input because of this OR gate. So that's the way we're going to think about this. For each bit, we're going to see if we can draw a very simple path through to the output and work out kind of a basic sort of logical rule. So we can say that if the least significant bit is 1, then the bomb won't explode. Now what about this bit? Okay, so these two bits I'll get back to in a sec. So let me grab a different colour. These two bits here both feed into our OR gate. So if either of these bits are high, then the bomb will not explode. So we're going to need to count down to, at the very least, the value 1, like 1, 0, 1, 1. Oh, sorry, 1, 0, 1, 0. Okay, now let's have a look here. We're feeding into a NOT AND gate. So we want any situation that isn't AND. Okay, so if these two, let's write a quick truth table for this NOT AND gate. We'll have A, B, and A, NOT AND B. Right, so A, NOT AND B, that's going to be 0, 1, 1, and 1. Now if we remember from our NOT OR up here, we're aiming to keep always at least one input to this NOR gate high. So the output of this gate will be high in any case except for both of its inputs being high. So that will occur when this bit is low and this bit is high. So I think we'll find that the first number which will set off the bomb is going to be 0, oh, sorry, it's going to be 1, 0, 0, 0. Now let's have a think about this for a minute, and let's count down in binary over here. I'll have 1, 1, 1, 1. Okay, so let's go through all of our cases on the left over here and see what we think. So we know that if either of these bits are high, this OR gate will be high, there will be a 1 on the input of the NOT OR, and any case where there is a 1 on the input of the NOT OR, the output is 0. So we can immediately discount any value which has a 1 in this column here, or this column here. Okay, so where's my black? It ain't going to be this one, this one, this one, or this one, and it's not going to be this, this. Okay, cool. So, what does that leave us with? So we have these two bits here, which I'll draw in orange. Okay, so these two bits here. Now these go into our NOT AND gate, and one of them is NOTed. So our NOT AND gate will output a 1 to our NOT OR, in every case except when the inputs are identical. Now if we remember, this bit has a NOT on it. So if this bit is high and this bit is low, that's the only condition when NOT AND is going to output a 0. Because the NOT of 0 is 1, and we'll have a 1 here. We'll have two 1s going to our NOT AND, which is this line of the truth table here, and that'll give us a 0. So we need to go through our number combinations here and cross out anything where the most significant bit, or bit 3, is 1, and bit number 1 over here is a 0. So we have a 1 here and a 1 here, so that's not going to output 0 on this gate. We can cross that off, and oh, what do we have here? 1 on this bit and 0 on this bit. So let's write this in here. Okay, so this would be an 8. Now I'll draw in orange bit paths which are positive or high. So this is all going to be low, that's okay. And this will be a 1 here. Now, NOT AND. This is the input combination. 1 and 1, because this is going to be high as well. 0, not 0 is 1. Okay, so we have two 1s, so we have a 0 out here. And we have a 0 in here, so this is going to be high. That's this line of the truth table here. So 0 and 0, and oh no, our bomb has exploded. So that's how I would think through working out when the bomb's going to explode. Essentially, I've derived a few small rules in my head, and then I've just counted down and eliminated any until I've found the first one that makes the bomb explode. So let's think about part 2 now. Imagine you have one battery which you can attach to one of the 4 counter bits to keep it at 1, regardless of the state of the counter. Is there a single counter bit you could attach it to stop the bomb from going off? So I worked out before that if either of these bits are high, then this wire is going to be 0, because if either of these bits are high, the output of this OR gate is going to be high, which means our NOR gate is going to have at least one positive input, so it'll be one of these cases, which means the output will be 0. So if we were to keep either of these two bits high, that would prevent the bomb from exploding. So that's an answer for part 2. If we keep bit 0 high or bit 2 high, then that will prevent the bomb from exploding. Now, can we do that with any other bits? That's a good question. Yes, I think we can. I think we keep bit 3 high as well. That will... Yeah, if we keep bit 3 high as well, that will mean that one of the inputs to the NAND gate will always be 0, because if we keep this at 1, then this will be not 1, so that'll be 0, and one input to the NAND gate will always be 0, which means that we'll never see this top case here. So we'll only ever see one of the 3 bottom cases with a 0 input, which means we'll always have a 1 on the output of this NAND gate, which means we'll always have a 1 on the input to the NOR gate, and that will also do the job. So if we can keep any bit other than this bit high, that will prevent the bomb from going off. So that, yeah, there's 3 correct answers to part 2. Alright, so part 3 is writing some assembly language programming, and I'm going to quickly move to the computer.